Hello friends, I welcome you all to this session on C programming. So before I start solving few problems with you, let me tell you something very interesting thing about loop in C, that is specifically for loop. Now in the previous lecture we have seen that this is basically initialization, then condition, then incrementation. Okay, and then the body. Now, it is not at all necessary that it has to be incrementation only, it can be decrementation depending on from where I am starting or what I have to use. Okay. Friends, remember that every part used inside this bracket parenthesis is optional. Yes, you have heard it right. Every part is optional. Let me show this to you. So, first, now let's say I just want to print I. Okay, I just want to print I. Now, what this program is doing, it is initialized with something declared initialized. Then the condition says stop when n is there, when I becomes equal to n, and then increment. So if I run it, let's say 5. So it will run up to 5. 1, 2, 3, 4, 5. So that is the basic classic example of a for loop. Now the question is, what if I remove this initialization part from here and I bring it outside? Am I permitted to do it? Yeah, you are always permitted to do this. Here is what the moment you do it outside, then that is what we call as using pre-existing variable. Okay, so what I do now here is I'll remove this part and now I'll write it here. Now what is I? I is a variable which exists before the loop and it is initialized also. So this is what we call as use of pre-existing variable inside the loop. Condition and update will now will be controlling the loop. Okay. So now if I run it now, what will happen? Let's say 5. Nothing, same thing. So uh, where can I use this elegantly? Now let's say I have to print the digits of any number. Okay, I have to print what? I have to print the digits of any number. Now n is already declared variable and I also know. Okay, now if I remove it for the time being and I set a condition that run this loop till this number is more than 0, and then you all know what we have done in that program in case of while loop. We every time we printed that last value, we remove that last value by using integer division. So what I'll do here is uh, n will be equal to n by 10. That's it. And if I print n now, or what I'll do, what I have to do, I have to print this remainder now. So if I print this remainder now, what is my remainder? It is n modulo operator 10. So what will happen every time the starting with, let's say, number 1 2 3. So n is already defined, it is predefined now. And if I say n is more than 0, if I'll check, so 1 2 3 is obviously more than 0, so it will come inside. Then it will do what? It will find the remainder, that means 1 2 3. So 3 will be coming out and then it will be going up, reducing it by that number 3. So it will become 1 2 now, and then this will go till the number becomes 0. So if I run this program, let's say my number is 1 2 3, so I'll be getting 3 2 1. So in this way you can write the same program which you have written in using while loop. Okay, so here what we are doing is we are omitting that initialization part from the loop construct, and we are now using, or we have to define it somehow. Okay, so we have defined it previously. So pre-existing variable, this is what we call. Okay, now let us do what? Let us write the same thing here. Control X, I'll write it here, and till I is, sorry, I is less than equal to, let's say, n, and then I will be incrementing I. Okay, now if I print this I, you all know what will come. Is there any mistake? Yes, it should be n. So if I print this I, so let's say up to 5, so it will print 1 2 3 4 5. Now look, the second thing has come. So previously I have omitted that initialization. Now I will be doing what? I will be omitting this condition. First I will omit it, and then I will show you what will happen and how to handle that situation. Am I permitted to do this? Yes, you are permitted to do. There is no problem. So if I run it now, friends, you know what will happen? The moment you omit the condition, the program will become an infinite loop. It will run for infinity. And in that case, you have to have break statement to come out of the loop. Yes, let me run it. So if I say n is 5, so what will happen? It will run because there is no condition. It will run for infinity. So by omitting the condition, what we have done is we have created a loop, that is for loop, which is running up to infinity. And if we have to come out of this particular situation, then we have to use break. So break is something which normally we use inside a loop to come out of that loop before the condition of that loop becomes false. So here, this is what, this is an infinite loop. Okay, I have to print 1 2 3 4 up to n. Okay, now I'll say if this I, that condition I'll paste here. Okay, if the I is uh, more, now I have to write like this. If the I is more or equal to n, then what I have to do? I have to break. That's it. Break means come out of the loop. So break statement is that statement which will force the control to come out of the loop the moment this condition becomes true. So now what will happen? First, I is 1. Is I more than n or equal to n? No. So it will not go inside, it will print, then I become 2 and so on. So if I run this program now, let's say 5, then it will do 1 2 3 4. Why it is not doing 5? Why? Is there any problem with the program? Now this is something which you have to think. Why I am not getting that 5 printed here? Though I have said that I is more than equal to n. So if I write more and then I write 5, so it will print 1 2 3 4 5. Okay. So these types of juggling you should always do with your program. So now what we have learned so far, the first thing is, in case of for loop, condition, initialization and incrementation, they all are optional. I have shown you two things. That is, I have removed the initialization part. I have removed the that condition part, and I have shown you. Now the third thing. So previously, let me write the program again as such. Then this is I is less than equal to n, and then this is I plus plus. So what if I remove that incrementation part? So if I run this program now, what will happen? If I write 5, so again this will happen, because I is always will remain 1 because there is no incrementation. So Am I syntactically permitted to do this? Yes, you are. Syntactically, there is no problem, but logically, there is a problem. Then, what you have to do inside this particular loop, you have to increment it. So, once you print it, then you have to increment it. Now, if I run it, let's say 5, so it will give me 1, 2, 3, 4, 5. So, friends, that is how the all the three parts of for loops are optional. Okay. Now in this lecture, I'll stop here and then I'll continue from where I have left. So remember, I have taught you three things today, that all the parts in for loop, that is initialization, incrementation, and that condition, they are basically optional. If you remove the initialization part, what you have to do it, you have to pre-initialize. If you are removing the condition part, then you have to write that condition inside the for loop using if, and then you have to use that break, otherwise the program will go up to infinity. The third, I have shown you that you have to use that incrementation. You can remove it, but you have to use it inside. So you have to somehow increment the loop. Otherwise, how will that condition be met? This condition will never ever met. I will remain always one then. So in this lecture, till this point only, in the next lecture, we will be clubbing these two together to make some new exciting conclusions. So in this lecture, till this point only, I'll see you in the next lecture. Thank you very much.